Okay, so we just finished up 4.1. So now we're on to 4.2, which is all about law of logarithms. So we saw last time in 4.1, just a few properties of law of logarithms. Two of them came from, whatchamacallit, properties of inverses, and the other two came from properties of exponents that we saw before. So if we were an in-person class, we would have a beautiful discussion about this, but like, are logarithms exponents, and can we apply the same exponent rules to them? So that's kind of like the derivation and like the reasoning behind the law of logarithms. So we saw in 4.1 that log base A of B equals X. If and only if, remember the scorpion tail, so A raised to the X equals B. So A to the X equals B. And then we can kind of go take another step and see that, well, X equals log base A of B. So I can put that into the exponent. Log A, B, and that would equal B. And that is an inverse property that we saw last time. So that's kind of what we are talking about today. And usually what I will say along the lines of like, logarithms are just exponents, right? They answer the question, what do I have to raise A to get to B? Okay, so from exponential rules, we know that A to the X times, not A, 10 to the X times 10 to the Y is 10 to the X plus Y. Bases are the same when they're multiplied, exponents add. So let's call A 10 to the X, and let's call B 10 to the Y. Then A times B, right? So this is A, this is B. That would equal 10 to the X plus Y. So then we can apply logarithms. That should be an I right there. And we can see that, so log base A of 10, that's going to be like log base 10, 10 to the X. What can I raise 10 to get to 10 to the X? Can raise it to the X power. Similar for log 10 of B, log base 10 of B. So it'll be like log base 10, 10 to the Y. What can I raise 10 to get 10 to the Y? I can raise it to the Y power. And for log base 10 of AB, we know that's going to be 10 to the X plus Y. So that's log 10 to the 10 X plus Y. And similarly, that's going to be X plus Y. So then we can see that log base 10 to the A plus log base 10 to the B is going to be X plus Y, which also is log equals base 10 to the A times B. So from there, we can kind of see that if two logarithms are added together with the same base, similar to how exponents work, the same base, when I add them together like this, I can put them in one logarithm and multiply them. Okay, so we also have similar law of logs as well. And this kind of is also going along the same lines as they have the same base. Okay, so I have log base A, little a, to the big AB. We just saw that I can add those together. So that'd be log base A, log base A to the B. So I can expand my logarithm, so create more logarithms from going from log base A to the AB. And then I can expand it doing log base A, big A, plus log base A, big B. Okay. What if they're divided? Well, B here is technically like to the -1 if it's in the denominator. So we can have log base A of A minus, so if it's separated by division, it's a subtraction. Log base A of B. And remember, this is like in the logarithm. This is not log little a, big A divided by another logarithm. It's inside of the logarithm. And then the third law of logs, really useful one, is if I have an exponent inside of my logarithm, it becomes a coefficient. So the c will drop down and we'll have log base a to the a. So c times log base a to the a. And this kind of log 3 is kind of similar to when we had like x to the a to the b, be like x a times b. So that's kind of like a similar one to where that comes from. Okay. So if the inside of the log are multiplied, I can expand them using addition. If they're divided, I can expand it using subtraction. And if there's an exponent, I can turn it into a coefficient. Similarly, I can combine all my logarithms. So if they're all added together, they'll insides will multiply. If they're divided, if they're subtracted, they'll divide, and vice versa. So we'll go through a few examples of expanding and combining logarithms. So let's evaluate the following. So we can either, sometimes it's better to combine things into something rather than do each logarithm on its own. So we have log base 4 of 2 plus log base 4 of 32. I don't know what log base 4 of 32 is. I know log base 4 of 2 is probably like 1/2, but I don't know what 32 is. That seems kind of hard. So let's combine them, combining them into one logarithm to see if it works. And we can do that because they do have the same base. So log base 4 of 2 plus log base 4 of 32. So be log base 4, 2 times 32. And then we'll say like that was law 1. And then we can 2 times 32. It's going to be 64. So, excuse me. What is 64? So 4 squared is 16. 4 cubed, be 4 times that. Should be 40 plus 6 times 4. Yeah, 64. There we go. So log of 4 cubed would just equal 3. So that was a lot easier than trying to figure out log base 4 of 2 and log base 4 of 32, especially since they didn't show up on any like integer scale. Okay, so that's why it's useful to know these things when you're evaluating logarithms. So next one, log base 2 of 80 minus log base 2 of 5. Log base 2 of 5 is, I literally don't know. It's not even like a fraction like 1/2 or 2/3 or something. So this is where the law of logs are really useful. So log of 2, 80, so they're subtracted. So when I combine them, they're gonna divide. And the one that's being subtracted from is the denominator. So this is law 2. So be log 2 of 16, which is 2 to the 4th. That's just going to be 4. Okay. Equals. Additionally, we can do, so let's do one using law 3. So I have negative 1/3 log 8. This one you can see doesn't have a base. If no base indicated, the base is 10. So kind of like how in cube roots, we write the 3 on the radical, but if it's a square root, we don't. So log 10 is a very used log. So we use it so much that we just assume if there's no base, it's just log 10. So it kind of goes along the lines of that radical for square root. It's so used so much that we don't even need to put the 2 there anymore. So if there's no base, we just assume the base is 10. So Law 3 says that we can even write log base 10 if we wanted to, that coefficient can become an exponent. And now we can use exponent rules. So a negative exponent switches my fraction. So this is like 8/1. So it's going to be like 1/8 to the 1/3. And then I can apply the exponent to each in the numerator and denominator. So 1 to any root is just 1, and then it's to the cube root of 8, which we know is just 2. So we'll have log base 10 of 1/2. This one we don't actually really know at all, but I've evaluated as far as I can go, basically getting me down to the smallest number of calculator buttons, if you want to think about it like that. But that's as far as we go. And if we had a calculator, we would see that that is negative 0.31. But I am more than happy to have it like that. Okay. And I think that example is actually just should not be there because we've already done that example. All right. So those are 3 different ways to use the law of logs. So now when we're talking about expanding, it's kind of like I want one thing in each logarithm, and I want that one thing to be raised to the first power. Okay, so right now we have log base 2, 6 to the 6 times x. So if I want to expand log base 2, 6 plus log base 2 of x. Okay. And this is useful when we're solving for x. I want to get things away from x. So I would expand like this. And x isn't squared, it's already to the first power, so I don't need to do anything with law 3 at all. So that we use law 1 right there. And log base 2 of 6. I don't think we can, I don't think we can make that any smaller. Maybe if it was like 4 we could, but I don't think so. All right, so this is the next one, log base 4 z squared divided by y. So let's get each variable in its own logarithm, and then we'll talk about powers. So z squared divided by y. So law 2 says that this is going to be log base 4 z squared minus log 4 y. But we're not done expanding yet. So there's a y here to the first power. Great. But I have a z squared. So z squared. There we go. I need to keep expanding it. So the 2 is going to come down front. So 2 log base 4 z minus log 4 of y. So that was, this was law 2 and law 3. So I need that anything that's in this logarithm needs to be to the first power if it's a variable, and it can't have any other variable in it. So if I have like xy, it's now go, right? So let's look at this next example. Log x cubed times y to the 6th. So I would do anything that has to do with addition and subtraction first, and then exponents, right? So I wouldn't try to bring down a 3 and the 6 and try to think of how to bring it out like that. I would just separate them first and then worry about the exponents. So log 5 x cubed plus log y, oops, that looks like a g. There we go. And that was using law 1. And then the exponents are going to come down. So it's going to be 3 log 5 of x plus 6 log y. And that was law 3. And that's it. I think this stuff is like, you're just using like maybe like 5 rules, including the properties of logarithms, to like do these expansions and combinations. And that's why I like them so much, because I think they're pretty fun. So again, if there's no log, we assume it's log 10. And if you want to write log 10 in your answer, it's totally fine. So there's lots of ways to do these expansions in different orders and get to the final result. So we have AB divided by the square root of C. So I would get rid of the division first. So I do like log 10 AB minus log root C. And then I would do A plus log B. And when you're first working on these, if you're new to logarithms and new to these laws, I would do just one law per step instead of like trying to do multiple ones, because you could have gone from here to here really fast. But I would just try to do one step at a time so you're not like confusing yourself. And then that root, we can think of it like a square root. So square roots we can rewrite as rational exponents, so like 1/2. So the 1/2 would come down and we'd have log 10 of C. All right, excuse me. Whew. Okay, so that was how we can expand. So you can see each log has one thing inside of it, one number, one variable, and each one of those variables is raised to the first power, because any power we can just move out front. So that's what we mean by expanding. So now when we're talking about combining, I want to go the other way. It's kind of like factoring versus expanding. I want to make it all into one logarithm. So I only have one log involved, or as minimum as I can have. So just like we worked with addition and subtraction first, and then the exponents, let's do with the exponents first. Okay. So 3 log x would turn into log x cubed, and 2 log x minus 5 would turn into log x minus 5 squared. And so that was law 3. Now we can add them together. We couldn't multiply them together yet, just because I had this 3 and the 2 that are kind of bumping in my way, right? Law 1 states that it's like log A plus log B is log A times B. It doesn't have any like 2 and 3 in front of it being like 6 or something. We don't know that. So we can't say anything about when numbers are in front of those logarithms. So we have to get rid of them by putting them as exponents first. All right, so then when we combine them, using law 1, we'll have x cubed, and then x minus 5 squared. If you wanted to, you could FOIL this out and like really expand it, but I just think writing it like this is more than fine. I wouldn't go through the trouble of FOILing out and then missing something and then having a little bit of an error. So this is more than perfect. Okay. All right, next example. Okay. Oh, the next part's fun. Okay, cool. So like we said, before we can divide these things, because there's that negative, we need to get rid of this exponent. So 3 log 5 is going to turn into log 5 cubed minus that 1/2 is going to turn into an exponent. You can write it as a radical if you want. You don't have to. Just put it up in the exponent. All right, and then that division comes from the subtraction. So 5 cubed over root t plus 1. Do parentheses here. I wouldn't worry about rationalizing the denominator in this situation. I'm really care about if you know how to use law of logs. I'm not looking for if you know how to catch that. Okay. So writing it like this is perfectly fine. Okay, so with these different law of logs, so we can combine them, so make everything into one logarithm, or I can expand them where each logarithm has one thing inside of it raised to the first power, okay? And you'll get a lot of practice on your homework on doing that. So if you look at like your normal calculator, like your TI, or even on the Desmos scientific calculator, there's only 2 logarithms that show up. One we haven't talked about yet, one of them is log base E, or E is a number, that's ln, the natural log. But, and we talked about this before, but if there's no base listed, it's log base 10, and that's the one that's on your calculator. So you really only have these 2 logs, but like we've worked with log 2 before, that's a very common logarithm. And we've seen other logs, log 5, 8, 16, whatever. So like, how am I going to be able to like calculate a logarithm if in my calculator, if I only have those 2? So we need to be able to write logarithms in terms of other bases, pretty much. So this is where the change of base formula comes into, and it's pretty cool. So say I want to change it into base A or something, but I have log base B right here. So I have log base B of X. I can then write log base A of X divided by log base A of B. The logarithms are divided. So this is not something like I subtracted or whatever. It's not like that. The logarithms are divided, not the insides. So A is usually 10 or ln or whatever we want it to be. And the way I remember which one goes on top and the bottom, we can see that log and X are kind of on the same like playing field, and then B is like a subscript. So since B is a subscript, it kind of is intuitive that it would be in the denominator below a little bit as well. You can see X is a little above the B. So X would be the numerator and B within the denominator, and they have that matching base. Okay, and remember, we don't have any rules about combining logarithms that are actually divided by each other. Okay, so if we wanted to find log base 8 of 5, I'd be like, oh, I do log base 10 of 5 over log base 10 of 8. And then I would go to my calculator and do that. And I would see that it's 0.77398. So go to your calculator now and see if you can get that number. And if you don't, try again. And then if you don't again, come to office hours. All right. So that's all for law of logs. I think it's pretty fun. I hope you do too. All right. So we have one more lecture for the week, and then you guys will be done for your second and last week of class. So fun. All right. I will see you next time.